So with this electron, with a realistic mass, with a realistic charge, being fired between two plates, so that the plates, like the plates we've talked about before, we called them acceleration plates. Sorry, we should call the left-hand plate negative because this is an electron we're firing this time. And the right-hand plate positive. 10 to the power of 4 volts. 3 times 10 to the power of 4 volts. I'd like to get my electron to fire from the negative side, zip, over to the positive side, and then get ejected out the positive side. And we'd like to figure out what the velocity of this particle is as it gets fired out the positive side. So in the past, we've said that negative Q times the change in voltage is equal to the change in kinetic energy. Now in this case, change in kinetic energy is EK2 minus EK1 as always, but EK1 we've said is approximately equal to 0. We're going to say that the electron gets provided to this system with about a kinetic energy of 0. So that guy eliminates out. And we say that negative Q delta V is just going to be equal to EK2. Now EK2 is 1/2 mv squared. Don't get the V's mixed up. One is voltage, one is velocity, or speed rather. So we use a capital V for voltage. We can multiply both sides by 2, negative Q delta V over M equals V2, square root both sides. Now,
You can't square root of negative.
yeah, that's the problem. When we talk about negative, or when we talk about voltages, when we're accelerating negatives, the voltage has to be a negative value. The electric potential difference, I should say. I shouldn't say voltage. That's so slang.
Should this be like a really big value again?
Yeah, it'll be pretty big. 10 to the power of 8. I think it'll be slower than the speed of light this time.
2 million.
Yeah, half the speed of light maybe. Still pretty fast, and whether it's realistic or not, at least we didn't break any laws this time. And I'm only dropping off the units because it won't fit onto my page with my fat markers. Don't you do that.
Isn't that negative 2?
Yeah, I'm going to drop the negative off of the voltage too, though. Oh no, I put the wrong value in. I put the mass in where I should have put the charge. Nuts. Nuts. All square rooted. And you get about 1.027 times 10 to the power of 8 meters per second?
Yes.
Yes. No, I had it figured out beforehand. I wish I did that. No, I mean, yes, I did that in my head.
Should have just lied.
Should have lied. But then I'd have to keep it up. And all these lies snowball. Oh my gosh.
And you'd start asking you insane questions. And
Yeah.
you would do-
Try and do these crazy scientific notation calculations. What's that? Yeah.
Look what it's going through. I'm off right now.